Instructions for the operation of the Briggs Engine Cooling System Analyzer. The Engine Cooling System Analyzer is designed to make possible a complete analysis of the automobile cooling system under actual operating conditions. Most service personnel have discovered by simply following the operation instructions contained in the blue brochure and listening to the tape, they are able to perform a complete analysis on the very first automobile or truck they attempt to test. You will see for yourself and agree a cooling system diagnosis is a very simple process. Step 1. Start connection with a cold engine. Using the radiator drain plug, drain the coolant into a clean container to a point just below the level on the top radiator hose. This will prevent the loss of antifreeze during hookup of the analyzer. Check condition of the coolant in the container. If it is milky in color or excessively dirty or rusty, flush the system prior to testing. Failure to do so could cause damage to or malfunction of the analyzer. Step 2. Disconnect the top radiator hose from the radiator and connect it to the inlet pipe of the analyzer. Connect the outlet pipe of the analyzer to the radiator. Use reducers, hoses, and elbows as necessary, and be sure all clamps are tight. You will note that the Briggs Engine Cooling System Analyzer comes equipped with an assortment of connectors and reducers to be sure that you will be able to hook it up to any size radiator having a 1 1/4 inch to 2 inch opening. Step 3. Measure the width of the core on a downflow radiator or the height of the core of a crossflow radiator, and determine by visual means the number of rows of tubes that make up the thickness of the radiator. This can be done by using a flashlight and looking into the opening of the radiator, or sticking your finger into the opening and counting the number of tubes. There should be from 1 to 4 rows of tubes. Check these two factors against the gravity flow table on the side of the analyzer, which will determine the proper gallons per minute or GPM flow rate for the radiator that you are testing. This flow rate will be used when you perform tests 6, 7, and 8. Pour coolant to overflow level and install radiator cap. Using an antifreeze gallon jug filled with coolant or water, connect quick disconnects to top of analyzer and invert jug above analyzer, filling completely with liquid, which will remove air at the same time. Once analyzer is completely full of liquid, disconnect quick disconnects. Warning: never reconnect quick disconnects to analyzer with pressure reading on analyzer gauge. Step 4. After analyzer is filled from the filling bottle, plug in bulb pump with valve closed. Pump pressure into system to 10 to 17 psi. Disconnect pump. Inspect for water leakage from entire cooling system. Once inspection is done, plug in bulb pump and release pressure from system with valve on pump. Disconnect pump. If needed, add coolant to system with filler bottle and disconnect filler bottle. Step 5. Place a thin sheet of cardboard directly in front of the radiator. This will speed warm-up and will make testing much more efficient. Best testing results are obtained with temperatures above the thermostat rating. Temperatures of 210 to 220 degrees Fahrenheit usually get good results if the system is pressurizing. Be sure to turn the air conditioning unit off before testing when using cardboard or other airflow obstructions in front of the radiator. Step 6. Start the engine and set the throttle at a fast idle to bring the engine to operating temperature. Observe the condition of the coolant as it flows through the analyzer throughout the test. If testing a very dirty system, the flow meter ball may get stuck in the flow chamber. This requires the removal of the analyzer. See Step 7 at end of test number 8. Step 6A. Tip the analyzer upside down and strike the side of the flow meter chamber with a screwdriver handle. This will release the ball. Remove disconnect from chamber. Clean thoroughly with the brush. If the ball is lost, it must be ordered from us because of size and weight for exact flow meter readings. Step 6B. Flush engine cooling system and retest. Test number 1. Thermostat. Stuck open or no thermostat. When the engine is first started, the ball of the flow meter will immediately start to register gallons per minute. The gauge on the analyzer will also indicate a temperature considerably below the normal thermostat opening temperature. be stuck shut. Lack of circulation will cause the engine to heat up quickly, and the gauge on the analyzer will soon indicate a temperature above the thermostat rating. There will be no GPM readings at any time. C. Operating properly. When the engine is first started, coolant from the engine will begin to mix slowly in the chamber of the analyzer. When the thermostat is fully open, the ball in the flow meter chamber will move up and down very slightly in the bottom of the flow meter. The ball will not move until the thermostat is full open, at which time set red arrow on gauge face to opening temperature for future reference. D. Operating temperature. This test must be performed with no airflow obstruction in the front of the radiator. Therefore, it can best be performed at the end of all other testing. Remove radiator airflow obstruction and set the engine at fast idle. The temperature readings on the analyzer should drop gradually and hold steady at some lower reading. This will indicate the constant operating temperature of the thermostat.